In this video, we will see difference between static and dynamic memory allocation. Let's start. First of all, see what is the meaning of the memory allocation. It is a process of reserving computer memory to store the variables, data structure and other information. It determines when, where and how much memory is needed. So there are the two types of the memory allocation. First one is a static memory allocation and second one is a dynamic memory allocation. Now we will see the difference between these both memory allocation one by one. Difference 1 is based upon the timing of the allocation. In case of the static allocation, memory is allocated compile time, means before starting the execution of the program. Once program execution gets started, you cannot increase and decrease the size of the memory. Example is int array 10. It means they will allocate the memory for the 10 elements to store the 10 integer values. In case of the dynamic allocation, memory is allocated runtime. Means once the program execution gets started, after that you can allocate the memory as needed. And for that you can use the malloc realloc function to allocate the memory runtime. Second difference is based upon the size. In case of the static allocation, the size is a fixed, means once we allocate the memory, we cannot change the size of that memory at the time of execution of the program. Example, if you declare the array of the 100 elements, then it remain exactly 100 throughout the execution. You cannot add one more element in such a cases. And in case of the dynamic allocation, the size can be changed during the execution of the program. As needed, we will allocate the memory. Difference 3 is based on the lifetime of the allocated memory. In case of the static allocation, if you are declare any variable within the function and when the function complete their execution, that time the memory which is allocated for that variable going to be released automatically. But in case of the dynamic memory allocation, you have to explicitly free that memory with the help of free function. Next difference is based upon the efficiency. In case of the static memory allocation, it provides a faster allocation as the memory is allocated compile time, as well as it provides the faster access to any elements of the static memory. But in case of the dynamic allocation, it is slightly slower than the static memory allocation because it has an overhead of the memory management. Every time you have to keep track about the how much memory get allocated. Next difference is based upon the memory reusability. In case of the static allocation, we cannot reuse the memory as it once allocated, this memory remains reserved even if it is unused. So it can lead to the wastage of the resources. But in case of the dynamic memory allocation, if you do not require that memory, you can free that memory and so that other can reuse that memory. With the help of free function, you can deallocate the memory. So this helps in optimizing the memory uses. Next difference is based upon the management responsibility. In case of the static allocation, compiler handles everything automatically. It means they will allocate the memory at the compile time as well as they will deallocate when the scope of the particular variable get ends. Because of that, it provides the less code complexity, but it provides the limited control for the programmer. In case of the dynamic allocation, manually programmer has to handle the allocation as well as deallocation. Because of that, it provides a full control over the memory, but the code is little bit complex and there is a risk of the memory leak as well. Now last difference is when I can use the static allocation and when I can go for the dynamic allocation. When there is a small and fixed size of data, that time you can go with the static allocation, or for the local variables arrays, when you know in advance what is the dimensions of that array, that time you can go with the static allocation. And in case of the dynamic allocation, when there is a variable size of the data structure, or you can use the dynamic allocation with the linked list trees like that. And when the your output is based upon the user data. Means consider user going to enter the value of n. Suppose user has entered the value of n is a 5, then I just want to calculate the maximum between 5 elements. If user enter the 7, that time I will calculate the maximum between 7 elements. It means here the you can say length of that particular list is based upon the user input. In such a cases, you can go for the dynamic allocation. Now lastly, we will see all this difference in the summary. As I said, in the static allocation done at the compile time. In dynamic, it done at the runtime. And here it's stored into the stack, and dynamic store into the heap. Now next, about the lifetime, it exists till the function ends and program ends, and it exists until the memory will be deallocated by the programmer. In case of the static allocation, size is fixed, you cannot resize. In case of the dynamic, resize of the memory allocation is possible. In case of the reuse, the static allocation, we cannot reuse that memory, but it is possible into the dynamic. The everything related to the allocation, deallocation, it will be handled by the compiler in case of the static, and about the dynamic, it will be handled by the programmer. About the speed, in case of the static allocation, speed is more, you can quickly access the elements, and in case of the dynamic, speed is slower. Example is, in such a type of, you can declare the array, and with the help of malloc also you can allocate the memory for that array. I hope you understand the difference between static and dynamic allocation. Thank you.